Okay, good morning. Test days tomorrow. So I have picked out several review problems from that page 416 and 418. I sent you the answers yesterday, so hopefully you've worked a little bit on that, or you plan to. All right, so I picked out a couple. Let's get started here. So number 29, this is on page 416. Number 29, it doesn't start out like that. I wrote it down, put together. Look in your book, get your book out. You'll see how the problem starts. I put it together because I'm noticing I can do some canceling. So that's why we put it together. So look at this. This 7 completely goes away, and the 56 is now an 8. And the y completely goes away, and 5 minus 1, so that's now to the 4th. So what looked like it was going to be a fraction, rationalized denominator, is not even going to happen. All you have here is the cube root of 8 y to the 4th. Much easier. All right, so I'm going to draw one of these so I have a place to put stuff. Picture that you're giving everybody the cube root. Cube root of 8, you should know that by now, outside 2. So then I have the cube root of y to the 4th. The index number tells you how you want to split it up. So this would be y to the 3rd times y. That's y to the 4th. So cube root of y cubed, outside y. This guy stays in. There's your answer. Number 34. So this one, it's split apart. I'm going to put it back together, and then I can do some canceling. So square root of 3x to the 5th over 8x squared. This completely goes away, and now I have 3 of them. Let's split it up, give everybody their own radical, and then we can work individually on those numbers. So the square root of 3x cubed over the square root of 8. Now, before you start doing your fancy number 1, why don't you break that down and make it smaller? Then you'd have easier numbers to work with. So, on the top, draw one of those. The 3 stays in, but look at the square root of x cubed. 1 out here, 1 inside. Make sure this radical sign extends far enough to include everything. Square root of 8, let's use 4 times 2. See up here it was a cube root of 8. Square root of 8 is different. Use different numbers from different lists. Square root of 4 is an outside 2. And there's the leftover. So your fancy number 1 just has this. Nothing wrong with that, just this. So square root 2 over itself. I'm going to go straight across the top and the bottom. I'll do the bottom first. So these two together turn into square root of 4, which is just 2, but you already have an outside 2. So the denominator is 4. Across the top, that outside has nothing to combine with inside. There you have it. Number 36 is just like that. I'm going to put it all together because I notice I can do some canceling. This 2 goes away, and now you have a 16 on bottom. This entire b squared goes away, and now you just have 1 because 3 minus 2 is 1. So let's split it up and see what we're dealing with. The top, square root of a to the 7th, which will break down, over square root of 16b. Okay. One of those. Split the 7 up according to the index, which is a 2. 7 divided by 2. That would be 3 on the outside and 1 left inside. The bottom, square root of 16 is outside 4, but then you have that, which is illegal, which you need to fix. Okay, So right here, these two together give me plain old b. But times it by the 4, the denominator is 4b. Go straight across the top, a cubed square root of ab. There you have it. Okay, another simplified problem. You can't have radicals in the denominator, so you need a fancy number 1, just like you saw on these couple problems. However, your fancy number 1 is made up of the conjugate of this. So the conjugate is 7 minus 2 square root 3. Let's put some parentheses. Let's do the bottom first. So the thing about the bottom is that because you've used conjugates, the O and the I will drop out. It's just fluff. So first with the first is 49. The O and I drop out. The L, the last, would be negative 4 times 3. So 49 minus 12. So the denominator is 37. And the top, distributive properties. 6 times 7, 42 minus 12 square root 3. That's all you do. That's all there is to it. Conjugate, made up, the fancy number 1 is made up of the conjugate, which is the opposite sign right there in the middle. All right, 46, I want to say something about 46. Hold on. Wrong way, there we go. So on 46, there's not a question on the test like that where you have to write from exponent form into radical form. But why we're going to practice this, though, is because if the directions were to simplify, which is on the test, then you'd want to know how to work with this negative exponent. All right, so first let's take care of the negative. This is over 1 right now. A negative exponent is going to shove it to the bottom. And now it's positive exponent of 3/4. So you have to illustrate, I know you can just use your calculator, but you have to use the definition of rational fraction exponents. I need to see this step. The denominator becomes the index. Now, I put that 3 exponent right in there because as I was writing it, I was thinking to myself, the 4th root of 2, I don't know what that is. So let's go ahead and call it 1 over the 4th root of 8. And just leave it like that. Okay, now on your test, you're probably going to have numbers that you can actually work with. The 4th root of 16, that's a thing, that's 2. The 4th root of 81, that's 3. All right, so that one's done for what we need to do with it right now. Number 49, right here. See, this is what I was talking about, the simplify questions. So don't just do it on the calculator. You can if you want to check, but I need to see this step. Watch. The 5th root of 243, and then the 4, the top number, then figure out what that is. Because guess what this is? Go ahead and guess. No, it's not 2. The 5th root of 32, that's 2. This is 3. Do it on your calculator. 3 to the 5th is 243. So this is 3 raised to the 4th, which is 81. Okay, number 52, I got the little star by it because the answer key is wrong. The answer key says x to the 1/9. I don't know how they got that. I just copied it down from the book when I sent it out to you. So now I've worked it out and I see that's not the right answer. Let's go through it. So what you need to do here is that rule about same base, add the exponents. So I'm going to keep that same base and I'm just going to set up a fraction addition problem. Do not change them to decimals. Just add the fractions. Common denominator would be 6. So this one stays the same, but turn that into a 6. Well, how does a 3 turn into a 6? You times by 2. So times the top by 2. 2 times 2 is 4. So your answer is actually x to the 5/6. I don't know where they got 1/9. All right, so I'm going to do this one. I need a little room. Let me erase this. And this. Just clear the space a little bit. Okay, now, on the answer key, I wrote a suggestion that said, you know, you could turn this into 3x plus 1 to the 1/3 equals -5. And then how do you fix the rational exponent 1/3? You raise it to the reciprocal. Well, what's the reciprocal of 1/3? Yeah, it's 3. So if I raise this to the 3rd, that would be the exact same thing, the same result, as if you took this original and cubed the cube root. Okay, so we wrote these out as two different types of problems. They're basically the same though. All right, so I'm going to raise both sides to the 3rd power. So I know what happens here. 3x plus 1. Over there, be very careful. It's the whole, with the negative, it's the whole entire thing that gets raised to the 3rd. So that would be -125. Okay, now solve for x. Sometimes we had to factor. You don't have to factor here. It's x to the 1. So -1 from both sides. 3x equals -126. Divide both sides by 3. X equals -42. And now the checking. Yes, you have to check on tomorrow's test. There's 2 equations, solve and check. So right here, let me show you how I want you to organize this. Check, -42. All right, so you always go back to the original. See what I've got circled there? So take -42 and plug it right there. Cube root of, okay, 3 times -42 is -126 plus 1. Does that equal this side? Does the left side equal the right side? So what not to do? Do not cube both sides. That's back here in solving mode. You are just working this thing out to see, does the left side equal the right side? Okay? So underneath there, I've got the cube root of -125. Well, that's -5. Does the left side equal the right side? Yeah, it does. So then use these little fancy set brackets that says, here's my solution, -42. All right, let's try a couple more. Okay, so number 55 is another solve and check equation. So you got to solve for x. Well, this one's fine out here, but this one is trapped under a square root. So to get it out, you will square both sides. Now here, that's going to mean FOIL. Going to have to FOIL. All right, so cancel, cancel. X plus 7 equals, write it twice, that's what that means, and then FOIL. So x squared plus 2x plus 1. Now, to solve a quadratic, you're going to either factor or use quadratic formula, and either of those methods, you have to have everything over here equals 0. And why we're putting the 0 here is because you want to keep the quadratic term positive. It's just easier for solving, for factoring. So I'm going to subtract x from both sides. And I will get 2 minus 1 is 1x. We're going to subtract 7. So you get a negative 6 right there. Okay, factor it. X, 3, 2, minus on the 2, plus on the 3. Use zero product property. X equals negative 3. X equals positive 2. Remember that shortcut we talked about? And now you have to check. So check negative 3. This is how I want it organized tomorrow on the test. So go to the original, which is right there. Plug in negative 3 everywhere you see an X. And then just ask yourself, does the left side equal the right side? So if I put negative 3 right here, you get 7 minus 3. So that's 4, but it's under a radical. And then right here, if you put negative 3 plus 1. So let's clean this up a little. Square root of 4 is just 2. Well, on the right side, 1 minus 3 is negative 2. That's not equal. No, that does not equal. So negative 3 is not one of the roots. That does not mean this automatically is the answer. You still need to check it. Check 2. Go to the original. Put a 2 wherever you see an X. 2 plus 7 is 9. Then there's an equals. 2 plus 1. Well, work it out and see. Square root of 9 is 3. Does this side equal 2 plus 1? Yeah, it does. Check. But you can't leave your answer like this. You have to summarize, a closure. I need you to do these brackets and look at how the answer, it's not 3. That doesn't go in the brackets. The X that gave you the correct left side equal right. That's what goes here. Okay? Okay, so on page 418, there's a lot of the same problems, but I picked out number 10 because we haven't yet seen one like that. It's a simplify problem, and simplify entails adding, subtracting, multiply, dividing. So let's, before we can add though, you need to have like terms. I don't have any right now. I have all square roots, that's good, but you need to have the same thing underneath. Square root of, it's got to be the same number. So you have to break these down. So this is 49 times 2. I'm thinking of my square, my list of squares. So that would be 7 square root 2. See, the list number is the one that comes outside. Not the actual 49. The square root of 49 comes outside. Right here. 25 times 2, so that'd be plus 5 square root 2. And then you have a minus, you can't do anything with that. Well, these two are what we call like terms. Think of it as 7x plus 5x. You know how that's 12x? Well, 7 of these plus 5 of these is 12 of these. And then don't forget this one on the end. There you have it. Okay? All right, so got to practice these tomorrow, taking our test. See ya. Good luck. Bye.